Hello everyone, this is Prashanth. In the last lecture, I have completed REST versus WebSocket, some key differences, just to which one to use for developing of the real-time IoT projects. So depends on the our application. Just we may use either REST API or WebSocket API. So for example, I want to develop some chart box or chart application. Just I use WebSocket API. For banking application, I use REST API. So depends on the application I use for REST API, whatever REST API or WebSocket API. So these are the things I discussed in the last class. Now I move entering into the under some, we have IoT protocols, different protocols here, like under the application layer, transport layer, whatever the layers here. Under the application layer, we have some protocols like here. Under the network layer or transport layer or application layer, just we have HTTP commands, CoAP, WebSocket, MQTT, XMMP, DDS, AMQP, like that. We have different types of protocols under application layer, transport layer, network layer, and link layer. So this is the topic here. Just comparison of HTTP, CoAP, and MQTT. So these are the two protocols under the application layer. It defines the application interface with the lower level application to send data over the network. That is the main aim of application layer. It enables the process-to-process communication using some protocols here. Under the application layer, HTTP protocol, CoAP, WebSocket, MQTT, XMMPP, DDS, and AMQP. So now what is the main definition of these protocols? Hypertext transfer protocal, that is HTTP, that forms the foundation of World Wide Web, www. Follow the request response model stateless protocol. So that is the first one. Next one, CoAP, constrained application protocol for machine to machine. Here one of the IoT technology associated with IoT technology, applications with constrained devices, constrained environments, and constrained network uses client server architecture. So that is CoAP. And the second one, WebSocket, it allows full duplex communication over a single socket connection. That is WebSocket communication, APS or communication model. And MQTT. So here message queue telemetry transport is high weight messaging protocol based on publish subscribe communication model. Use client server architecture, well suited for constrained environment. So that is the fourth one, that is MQTT, message queue telemetry support transport. So here next it is extensible XMPP, DDS, AMQP, like that. XMPP stands for extensible message and presence protocol for real-time communication and streaming XML data between network entities. Support client server and server communication model. That is XMPP. Next to DDS, data distribution service, is the data-centric middleware standards for device to device or machine to machine communication using publish subscribe communication model. The last one, AMQP, advanced message queuing protocol, is open application layer protocol for business messaging, supports both point to point and publish subscribe communication model. So these are the so whatever the available under application layer, HTTP, CoAP, WebSocket, MQTT, XMPP, DDS, AMQP, and protocols in application layer. Just we have some protocols here. Telenet, FTP, TFTP, NFS, SMTP, LPD. So the definition and the command for these two, this protocol. Telnet stands for teletype network. Teletype network. It helps with terminal emulation. It allows Telnet clients to access the resources of the telnet server, and it is used for managing files on the internet. So the command for this is telnet remote server. It's specify the name of the server just you want to connect. Next one, FTP. FTP stands for File Transfer Protocol. It is the protocol that actually lets us transfer of the file. It can facilitate this type of between the two machines using it. But FTP is not just for protocol, but it is also a program. So command for this is FTP. Just you can give the machine name. And TFTP. TFTP stands for Tribal File Transfer Protocol. It is stripped down stock version of FTP, but it is a protocol of choice if you know the exactly what you want and where it is to find. The command for that is TFTP options. Just you can give the command. And NFS, it stands for a network file system. It allows remote host to mount file system over a network and interact with those file systems as though are mounted locally. The command for NFS is service NF to start. And SMTP, so it stands for simple mail transfer protocol. It is a part of the TCP/IP protocol using a process called store and forward. SMTP moves your mail on across the network. The command for this one is mail from. And LPD, it stands for line printer demand. It is designed for printer sharing. It is the part that receives the process the request, a demand server on the agent. So that is the command for this is line printer daemon. So X-window or SNMP, the last one. X-window, it defines a protocol for the writing a graphical user interface based client server application. So the idea is to allow a program is called a client to run on computer. So the command for this is run XDM in run level 5. And SNMP stands for Simple Network Management Protocol. We already know. It gathers the data polling devices on the network from a management station at fixed random intervals, requiring them to disclose certain information. The command for this one is this one. Just you can copy that command to run the program. And DNS stands for Domain Name System. Time it uses a domain name. Therefore, a DNS server must translate the name to the corresponding IP address. That is command for this is IP configuration like that. That is DNS. And DHCP, it stands for Dynamic Host Configuration Protocol. It gives IP addresses to host. There is a lot of information a DHCP server can provide it to a host. When the host is registering for an IP address with the DHCP server. The command for DHCP server, it is clear IP DHCP binding. Just you can add the address for a particular on the program. So this is the some protocols available in the application layer. So next, what is a constrained application protocol here? It is a just with our topic is comparison of CoAP and MQTT. So here constraint CO stands for constrained application protocol. It is a client server based with is the protocol. The CoAP packet can be shared between the different client nodes, which is are commanded by the CoAP server. It is the main thing. And the server is responsible for sharing the information depending on its logic, but has not acknowledged it. This is used with the applications with which support the state transfer model. That is the what is constrained application protocol, CoAP. And the definition of CoAP. So here CoAP, a constrained application protocol, is a special web protocol for IoT. The first initial thing, the part of definition of CoAP, it is a protocol under the application layer. Just you can assume in that in your mind. It is a special web protocol for IoT in order to develop some type of web applications, and it helps simple devices in networks with little data and not much availability to talk with each other. That is the second one. And the third one, it's often used for things like smart energy and building automation, making it easier for IoT devices with limited resources to communicate efficiently. So this is the third 3-point under definition of CoAP. constrained application protocol under application layer. It is a special web protocol for IoT also, to develop the IoT real-time projects. So just depends on the application, just we may use CoAP protocol. And features of CoAP. So here in the conflict of MQTT versus CoAP, a constrained application protocol is made for IoT devices with limited resources. It helps devices talk efficiently using a simple design over the network internet also. And the CoAP allows real-time updates in low data situations, and its security features keep data safe. It's good for IoT applications that need easy communication and work well even with the devices that don't have the lot of resources. So these are the some features of CoAP as compared with MQTT also. In terms of security, in terms of communication, in terms of efficiently design over the internet also. And characteristics of CoAP. So here the UDP based CoAP uses instead of TCP, making it suitable for limited resources and networks. And HTTP like semantics. CoAP employs HTTP like methods like get, post, put, delete for interactions also. Multicast, it can provide multicast support. CoAP includes UDP's multicast feature, which TCP, when TCP is lax, transport communication protocol. And lower overhead. CoAP minimizes the protocol overhead for efficient communication in constrained movements. So these are the some characteristics of CoAP: UDP based, HTTP like semantics, multicast support, and low overhead of the network. And so this is the just diagram of CoAP here. It operates on a client server architecture supporting one-to-one communication similar to MQTT. CoAP also contains two main components here. One is the client and broker. The client with the help broker just client the information. The broker receives the information from the client to the send to the remaining last client. The CoAP device can request data from the server in a certain way, and the server sends the requested data. CoAP is like HTTP, supporting actions such as getting data, sending data, updating data, deleting data. It can work with HTTP and RESTful systems through proxies also. So this is the diagram of constrained application protocol, and these are the some constraints of comparison of CoAP and MQTT is very important in terms of abbreviation. In terms of basics of abbreviation, which type of communication is used to develop the IoT project, and messaging mode, which type of transport layer it is used, and header size, what is the header size, RESTful based or WebSocket full based, persistent support, message labeling, usability, security, effectiveness, and communication model. So these are the different features. Among them, just we can compare with CoAP and MQTT. That is the thing here. Abbreviation constrained application protocol, CoAP, MQTT, message queuing telemetry transport, and messaging mode. This is uses both asynchronous and synchronous messaging mode. This is uses only asynchronous mode by that is MQTT. And a transport layer protocol. This mainly uses user datagram protocol, that is UDP. UDP stands for user datagram protocol. But here TCP maintain transmission control protocol. So this is the to maintain the transport layer protocol, and header size is 4 bytes. Here 2 bytes. And RESTful based way. Yes, it is REST is nothing but representational state transfer. Representational state transfer. No, it does not uses REST principles. And persistent type, persistent support. It does not have as such support, but here it supports best suited for live data communication also. And message labeling. So it provides by adding labels to the messages, and it has no such features also. And usability in terms of security, it is used to utility area network and has security mechanism. It is used in IoT applications is secure. So that is the in terms of usability and security. Effectiveness in LNN, local area network, that is excellent. Effectiveness in LNN is lower area network is very low. And the communication model is one-to-one communication model followed by the CoAP, and communication model is many to many. It is followed by the MQTT. So these are the comparison of CoAP and MQTT, constrained application protocols, and message queuing telemetry protocol. Under the features are in terms of abbreviation, in terms of communication type, messaging mode, which type of communication model it is used. Message mode, both it is either synchronous or asynchronous, whatever, just it followed the message mode. And transport layer, which type of transport layer it is UDP, user datagram protocol. MQTT is followed by TCP, transmission control protocol, that is next one. And in terms of header size also, it has 4 bytes of size header. It has 2 bytes of size header. And RESTful based principle, it follows by CoAP, but MQTT does not follow any type of REST representational state transfer principles. And persistent type support also, it does not have any such type of support. It supports best used for live data communication also. And message labeling, it provides by adding labels to the messages. It does not have that type of features also. And usability and security in terms of utility area networks and has security mechanism. It is used for IoT applications in secure. Effectiveness is in LN is excellent. Effectiveness in LN is very slow. Last one, communication model, it follows the one-to-one, just the communication is going on only one server and one client. But here in MQTT, many to many. Many clients and many servers are opposite side, so the communication is going among the different clients and different corresponding servers. So these are the comparison of CoAP and MQTT. So this is the summary of comparison of CoAP and MQTT. So here both application layer protocol built for IoT environment, although they address different requirements. And CoAP is suited for confined situations due to its request response mechanism over UDP, making it suitable for applications with limited bandwidth and power. That is the second one. And the third one, MQTT, on the other hand, is built for dependable low bandwidth communication. Low bandwidth communication using TCPs, using transportation communication protocol, and publish subscribe paradigm, and making for ideal M2M machine to machine communication also. Machine to machine communication. Machine to machine communication with IoT framework also. So these are the some mechanism or application we are going to develop based on the features of CoAP and MQTT. So depends on our applications only, just we move to develop the real-time IoT projects. So some questions here, is CoAP stateless or stateful? Just some basic questions based on this topic. Is CoAP stateless or stateful? And give some applications of CoAP protocol. protocol. Is CoAP is better than MQTT? And what are the disadvantages of MQTT when compared with CoAP? And what are the 5 methods of CoAP? And what is a MQTT payload? So these are the some frequently asked short questions on both CoAP and MQTT topic. So the first you should know the full form. What is CoAP and MQTT? The full forms are very important. So based on that, just you go for further action. So these are the some references I used for this lecture. Tutorials.com, index.com, the IoT Academy also, just we use the link for this preparing this lecture, and comparison of both CoAP and MQTT. This is the textbook for Arshadip Baga and Vijay Madhuseti, Internet of Things, a hands-on approach. Just is available internet also, 2014 edition. Tutorial points at transport layer. This is index term, transport layer, and UDP in transport layer, and the IoT Academy for MQTT versus CoAP topic. So these are the references I used for this lecture. Remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.